Okay, so in this situation, kids, that we're talking about right here, we know that the difference between the left and the right-hand sum is how many feet? Again, it was 90, right? Okay, things I want you to understand is we want to try and shorten the amount of time right here. We're trying to shorten this time interval. It's going to be part of this formula down here to figure out how do we shorten the distance between estimates, okay? So I want you to notice one thing. It says the formula for difference between overestimates and underestimates are as follows, okay? Up above, which one has to be the underestimate? Okay, so this is going to be my underestimate. This must be my overestimate, and this is kind of like our guess or our approximation right here then for how far it traveled, using 2 seconds as our delta t. Okay, down here, kids, there's a formula for being able to figure out how much distance there should be between an overestimate and an underestimate. And in the example that we had right here, how much difference was there again? Okay, so in for this difference, you would say, well, we have 90 feet right here was our difference. That, my friends, was equal to the ending value. And when I say the ending value, it's like the y value, or the, in our case, it would have been the velocity. So if you look at that table there, what was your ending velocity? What was the last velocity recorded in that table? 60. Minus the what?
Beginning value.
So in our case, what was the beginning velocity at time 0?
15.
Okay? And then we're taking that times our time interval, which was delta t. What was that value again for delta t?
2.
Okay. Guys, no coincidence that this works out, but help me out with this. What's 60 minus 15? 45 times 2. Oh my gosh, that means there should have been a distance of 90 feet between my underestimate and my overestimate. Okay, so here's the concept that comes from this. Down below that, they come in here and say, okay, that 90 feet difference between the two, that's a big gap. We'd like to shorten that gap. So they come in here and say, how often would you need to record the velocity in your table in order for the total distance traveled to be within how much of each other?
0.25.
So they're saying, I want a difference from my underestimate and my overestimate. I only want 0.25 feet between that. 0.25 feet is, how do I get that within 3 inches, basically? Okay, how often do I have to measure that? What do you think is going to happen to that time interval? Shorter or longer?
Shorter.
We're going to have a lot more data to be that accurate, aren't we? Okay, we're going to use the formula right here. So I don't want the difference being 90 anymore. I want it to be how many feet?
0.25.
Okay, so I'm going to plug 0.25 in for my difference. Okay, now, you still have to use your beginning and your ending velocities. So what was the ending velocity again within the table?
60.
60. Minus your beginning velocity.
15.
Okay, and what we're trying to solve for is, up here we were going every 2 seconds. We need to know what the new time frame is that we're solving for to be able to say, hey, the left and the right hand sums are within 1/4 of a foot of each other. Okay? You think those would be good estimates then? Okay. Okay, so here's the idea that comes from this. This becomes 0.25 is equal to, you guys read it in parentheses, 45?
Yep.
45 times change in time, or how long our interval should be. Okay, what are you going to divide both sides by to find delta t?
45.
Okay, maybe this is a pretty small decimal, I know that. Oh, I don't want to divide by 0.45, I want to divide by 45. Okay, so divide 45, divide 45. Okay, what are you guys getting delta t equal to here?
0.005.
Like that?
Yeah.
You know, when I take a stopwatch like this, it only measures in hundredths of a second, like point, and then 2 places after decimal point. When I do this real quickly, hang on a second. I'll do this on my watch. The quickest I can do mine is 0.24. I would have had to do that 480 times in the amount of time I just did that. I didn't know you could do that. Did you just smack the whole thing and turn it off?
Yeah,
I always do that.
What?
People always ask me who have Apple Watches that don't know that. They're like, why'd you just?
I know now.
Oh, you'll do it all the time now. That's how I do it.
I didn't know that.
I can't stand looking at my watch and then just putting my hand down and letting it glow. I just can't do that.
Guys, quick question. Talk to me about this time interval. First of all, if you were doing this manually, would it even be possible to time every 0.005 seconds? Or every 5/1000th of a second? Probably not, okay? But here's the idea that we get. Guys, if I want to be within a quarter of a foot on left-hand and right-hand sums compared to the actual value, if I want to be within a quarter of a foot, are we talking about these interval lengths being really long on the bottom or really, really short? So short that these interval lengths, when we start talking about them, are going to start to approach what value? 0. Okay, that idea of approaching 0 is going to come up again, but this time it's going to be the base of a bar within a left-hand sum or a right-hand sum. It's going to be the base or the interval length of all of those bars in there, okay? All right, my friends, let me go ahead and stop this.